In this video lesson, we're looking at the easiest kind of chemical reaction for which we have to find the products, at least in a high school class. So let's talk about combustion reactions. Okay? In its broadest context, a combustion reaction is any chemical reaction in which one chemical reacts with atmospheric oxygen, and in addition to chemical products, it produces light and heat. So let me repeat that, okay? In its broadest context, and really we're not going to deal with the broadest context in here except for the definition. You need to know the big definition here, okay? In its broadest context, a combustion reaction is any chemical reaction in which some chemical reacts with atmospheric oxygen. Some chemical reacts with atmospheric oxygen, that's O2, okay, to produce, in addition to chemical products, energy products of light and heat. When we write combustion reactions in here, we're going to just kind of leave out the light and heat, okay? We're also going to limit ourselves to a very narrow category. It's the biggest category if you're talking about the type of chemicals, but a narrow category of reactants besides the oxygen. Now, in a combustion reaction, the reactant other than oxygen is a fuel, okay? That's just a term. The reactant other than oxygen in a combustion reaction is a fuel. And in this class, the only kind of combustion reactions you're going to have to worry about are those where the fuel is a hydrocarbon. Okay, in this class, the only kind of combustion reactions you're going to have to worry about are those combustion reactions where the fuel is a hydrocarbon. Now, so what is a hydrocarbon? Hydrogen carbon kind of sounds like what it is, right? Okay, and we've dealt with a lot of those already, haven't we? Because we learned to name organic compounds, right? Okay, so any of those organic compounds that contain hydrogen and carbon, I mean, we throw in some other things too, but for the most part, we're only going to limit ourselves to hydrogen and carbon in here, okay? Just hydrogen and carbon, hydrocarbons, okay? So it's got to be a hydrocarbon fuel for us. Now that's not the big definition. That's our narrow area we're only going to deal with in here. It's got to have a hydrocarbon, and it's got to react with atmospheric oxygen, okay? And if it does, it's always going to produce the same two products. So predicting the products of a combustion reaction for us is like the easiest category because it's always the same. You don't have to switch things around and move this in here. You don't have to do any of that, okay? So if we have any hydrocarbon, let's say we're starting with, well, let's do something really simple like methane. That's the simplest hydrocarbon. Methane is a gas. And atmospheric oxygen is O2. We're always going to produce the same two products, and we're not even going to include the light and heat in the reaction. Not right now anyway. We will in Unit 10 later on. When we get to thermochemistry, which is the unit, someone was asking about this earlier today in first period. That's the unit where we make ice cream. So, thermochemistry.
Wait, what unit is that?
Unit 10.
That's the last one.
Yeah, the last one. Yeah. Okay. She can add and subtract. I'm sorry, that was sarcastic. I should have said that. Okay. All right. So the products are always the same. Okay? The products are always, are you with me here? David, you follow me? Okay. Ian, you follow me here? The products are always the same. They're always carbon dioxide and water. Boom. Yes. Huh? I am doing what?
Triggering you a little bit.
Triggering you? Is that like you're going to go off on me?
No.
That's a death
Emotionally.
Oh. You know I'm just playing around, right? This is a joke. I'm trying to get a smile. You were smiling. Come on.
Are you recording this?
I am recording it.
Right now?
Yes, right now.
Oh my god.
Wait, so no, in 2014, that's when our videos are from. So like 2019, when we're seniors, like there's gonna be a little sophomore being like, what?
Yeah, and I'm gonna say that was Callan. Okay.
Wait,
All right.
I gave you permission to use my name.
What now?
Oh.
Well, I don't see your face on here, and I only use your first name. That could be
How many talents do
anybody.
you know?
Huh? Doesn't matter. I'm not identifying
You
you.
even know what my last name is? No.
I'm not identifying you. Okay. All right. So let's see. What were the energy products we're making now?
Huh? Light and heat.
Light and heat. So what would the physical state of water be if there's a lot of heat? You got it. In a combustion reaction, you have to list water as being a gas because of the heat. You follow me?
Are you gonna edit this? So that there's like,
Maybe.
there's like how to edit it.
What is the deal?
He's gonna cut out all the complaining.
Did I cut out the complaining from the videos you guys have seen?
No.
There you go.
They don't speak. Like the videos you show us,
it's
there's
just
one
you
kid in
talking.
the corner.
You
Going,
get so off. I told you, you're ADD. And those videos that you make us watch.
Can we get back on topic? Speaking of that, okay? All right. Look, that's all you got to do. With combustion reactions, this is like really easy. Now all we have to do is balance the equation.
So it's always carbon dioxide.
Do it. All right. This is flu and cold season after all.
Yeah, we know. I had the flu. I don't think I can get the flu. They had the shot in 7th grade and I still. They told me if you get the shot, you're more likely.
Funny.
If you
We're
get
doing the numbers.
if you get the shot, you're more likely to get the flu. Oh my gosh, when I had it in 7th grade, it was so bad. Oh my god, my mom, I cried.
keep the slips of paper that have a project numbers on it.
I should have realized that 1, 2, 3. 1, 2, 3. No, it's ABC. It's ABC is easy as 1, 2, 3. You're small, man.
All right. Everybody got it? Now,
I choose.
I will be putting your homework on Google Classroom because somebody has to leave here, and I know you guys have another 5 minutes. I will give the class one more practice problem before we're done.
Can you do it
Okay?
before 8 o'clock tonight?
9.
That's the plan if I don't have another teacher get sick on me in the last minute or something. So, all right.
So all you do is teach classes. Your life is chemistry.
Yes. Before you go and do this problem, let me just tell you something about hydrocarbons, okay? If it's a straight chain hydrocarbon, and this is a straight chain, if we have 1 to 5 carbons in the chain, we're going to say, well, that's going to be a gas. All right? If we have 6 to 10 carbons in a chain, we're going to say that's a liquid. And if it has more than 10 carbons in a chain, we're going to say that's a solid. So that's asphalt. Okay?
Wait, say that again.
1 to 5 carbons in a chain, we are going to say the physical state of that will be a gas. 6 to 10, we are going to say liquid. More than 10 carbons in a straight chain, we are going to say that's a solid. It's a bit more complex than that because hydrocarbons are volatile, so there's some wiggle room around those numbers I gave you. But to make it simple and easy, we're just going to say it's easy to remember 5 and 10. That's why I use that, and it's pretty close anyway.